13.
It is 13. Good. So this becomes 5 plus or minus the square root of 13 over 6. Is it clear why it becomes 5? The two negatives cancel out. 2 times 3 is 6. Just kind of 3 separate calculations there. All right, good. The part under the square root and something something to be on the lookout for. So now you're not done, even though you kind of are. Depends on how the answers are written. But you divide each of these. You divide each of these by the 6 there. So it ends up being 5 over 6 plus or minus the square root of 13 over 6, and that's your final answer. Any questions on that? Any thoughts?
No, it's just a little strange.
Yeah. Trying to think of a good analogy to music, but it's like the quadratic formula is the song that everyone knows. Maybe isn't your favorite, but everyone knows it's kind of okay. But a bunch more to do here. They're all kind of the same. This one is equal to 0, so you're already kind of set up and ready to go. The value of A is 2, the value of B is 2, and the value of C is negative. So what I would recommend, especially if you're going to do some of these on your own, is to do the discriminant first. Okay, so I'd like you to try that part for me, please. How are you doing on this one?
Pretty good. I got 28.
28, very good. The reason I have you do this part first is that when you write the rest of it, the minus b plus or minus the square root of b squared minus 4ac, that's the part under the square root. So that's kind of like, it's not really a shortcut, but it's just a way to break up the work to make it more manageable. When you're walking 2.5 miles, it's like just one more step, right? It's a long ways. Now, unlike the previous problem, you can reduce the square root of 28. You have to make a prime factorization though. Do you remember that?
Yeah. So 2 and 14.
Good.
And 2 and 7.
Good. And so if there's a pair of 2s, you bring the 2 out. 2 square root 7.
Yeah.
All right, so that's the part that becomes, it's minus 2 plus or minus, instead of square root of 28, 2 square root 7 divided by 4 now. And just like the last problem, each of them by 4. Now it's the number outside the root that you're dividing by 4, never the number underneath. Minus 2 over 4 plus or minus 2 square root 7 over 4, like that.
Can the minus 2 over 4 be simplified?
Yes, they both can. Yeah, they both can. And I wanted you to kind of see, show it, and then you perform the division. And this is it. This is your final answer. Yeah, this is X the whole way down.
All right.
All right. Questions on that? Thoughts? Anything kind of come to mind here?
No.
All right, let me look ahead here because I want to see if there's maybe some more difficult ones for us to do, or if they're all kind of the same or not the same. Yeah, normally I say let's do them from start to finish, but let's maybe start. Let's go to, for example, number 8 and just work from the rest of them from there. Is that okay with you?
Yeah.
All right, so x squared minus 49 equals 0. Can you give me the value of a, b, and c? And if you need to, look back at the previous problem because there's a kind of a subtle difference here. There's something that's missing.
C is missing.
So let me write it this way. Let's say it's ax squared plus bx plus c. C is always the number. Do you have a number here?
Yeah.
Yes. But do you have an x only term? Not an x squared, just an x only.
Oh. No.
No. So the b is what's 0. Like if you were to rewrite this, it's x squared plus 0x minus 49 equals 0. And what instructors like to do, teachers like to do, is they like to give you a problem that really should not be solved using quadratic formula, and then they ask you to solve it using quadratic formula. So a is 1, c is minus 49. So we have minus 0 for b, plus or minus the square root 0 squared minus 4 times 1 times minus 49, all over 2 times 1. All right, go ahead and calculate what's under the square root for us, please.
All right. Uh, 196.
Okay, and does that have a square root? Can you take the square root of 196?
Feels like a number that can be. 14.
14. So this becomes plus or minus 14 divided by 2. That plus or minus is paired with it, so it has to be part of the square root. Then you divide here, so that's plus or minus 7. Is that okay? Clear?
Yeah.
All right, let's go to number 9. I kept thinking you were gonna get beyond quadratic stuff. I mean, there is sort of a, it's like what will happen first, the end of the school year, or you guys will finish solving quadratics. All right, so the goal is always to get it to equal 0 on one side of the equation with quadratic formula. So you do have to move that 20 back to the left. You subtract 20 from both sides. 3x squared plus 8x minus 20 equals 0. And A is 3, B is 8, C is minus 20. So again, for this one, I'd like you to calculate the B squared minus 4AC and let me know what you come up with. Then we'll see how to proceed from here.
All right. I got 304.
Okay, I agree. So if you go back to the quadratic formula here, what goes first here? Do you remember the formula?
B.
Minus B.
Yeah, minus B.
Okay, so what goes first?
Plus or minus.
Minus A plus or minus, and then what comes next?
The square root of 304.
All over? What goes in the bottom?
2 times 3, so 6.
Good, really good. So just a few little things, right? Like it is negative B. You got to make sure that you do that. You got to multiply the bottom. Now square root of 304. Have you checked to see if that works out perfectly or not?
Not yet. I feel like it might. Maybe. No, not perfectly.
Okay, so we do have to do this horrible thing here where it's 2 and 152.
Oh man.
2 and 76. Yeah, I'm gonna help here. It's 2 and 38. 2 and 19. So do you see any pairs?
Yeah, 2 of them.
So that means for each pair, 1 comes out. So it's 2 times 2 square root of what's left over. What is left over?
19.
19. Yeah, so it becomes 4 square root 19. All right, so when you rewrite it here, what you want to decide is like, is there more to do? And this is the question I think most students ask. I mean, I ask it in other things that I do. It's like, how do I know when I'm done? And you have to decide if you can divide these by 6 and if something happens.
Yeah. Become
So you can't, yeah, keep going.
negative 8/6 plus or minus 4/6.
Yes, and each of those can be divided by 2.
So negative 4/3 plus or minus negative, no, just regular 2/3 squared 19.
Okay, good. All right, that's 9, so we're up to 10. I think we're finally up to one that has no solution. Did you guys talk about the complex solutions in class yet with i's and things like that? Square roots of negatives?
Yeah,
Okay, I think
the
that's
weird
coming.
little eye that looks like a J.
Yes, yes, and then actually in some textbooks they do use J, especially much older ones. All right, so what is the value of A, B, and C in this problem?
A is 1, B is 2, and C is 5.
Okay, and can you give me the quadratic formula here one time? I haven't asked for it yet, but I've written it down a couple of times. Could you just give it to me here, start to finish, just with the letters? You don't have to substitute in yet for it.
All right. Negative B plus or minus the square root of B squared minus 4 AC all over 2A.
Very good. All right, so I recommend you calculate B squared minus 4AC first. It also kind of clues you into the complexity of the answer, whether it's real, complex, or nice.
Minus 16.
Yeah, yes, minus 16. So this is the first time we've seen that today, and it can be a little bit like shocking when you have something just totally different here.
Yeah.
So we've got the square root of negative 16. Now, if it were just square root of 16, if it were just the square root of 16, we would know what to do. But it's not. It's the square root of -1 times 16, and you can break that apart as the square root of -1 times the square root of 16. And that's where you got to remember that I thing. So the square root of -1 is I. That's something you'll have to remember here for a while.
All right.
Square root of 16, that's 4. For I.
4, 5.
So that's the part of the square root. So notice we tend to come off to the side and figure that part out. And then we're going to divide everything by 2. So you're going to divide each of the. Yep.
-1 plus or minus 2I.
Yes. All right, so let's look at, I think 12 is going to be similar. So we'll do that one next. 11, I think actually has some roots. We'll see here. Let's go to 12. We'll come back to 11. We're doing pretty well in terms of time, so we might actually be able to get through. Go back to some of the ones that we skipped over. Here we've got A equals 1, B equals 6, and C equals 4. You want to, again, determine the discriminant. That's going to tell you a bunch about how to proceed.
Yeah. I got 20.
Okay. So B squared, we got 6 squared minus 4 times 1 times 4. So this one is just fine. It actually does have some roots. So this one is minus 6 plus or minus the square root of 20 over 2 times 1, which is 2. So the faster you can write down the quadratic formula and the numbers that go in there, the faster you'll be getting the answer. This one does require you to come off to the side and figure out what the square root of 20 is. Will you try that out for us, please?
Sure. I got 2 square root of 5.
Yes, 2 square root of 5. So we replace the square root of 20 with the 2 square root of 5. And then you'll divide each of these by 2.
So -3 plus or minus square root of 5.
Yes. All right, let's go back to 11. Got A equals 1, B equals 3, C equals -6. Will you calculate the discriminant again?
Sure. I got 33.
Let's see, 9, yeah, 33 this time. Yep, looks good. So that's the most important thing to get right. It's -3 plus or minus the square root of 33 all over 2. So can you take a look and see if the square root of 33 reduces or not?
It does not.
Yeah, it's just like that. So you can treat it like there's a 1 out in front if that helps, because you still have to divide each of these by the 2. So you may want to double check and see if your teacher's okay with how you've written this. It's usually acceptable, but
I'll ask.
yeah. I wish there was more standard. Just really depends on what the teachers want. Fortunately, it's just a notation. Right. We left off, I think, on 3, maybe. You want to double check?
Yeah.
Okay. Any of those stand out to you? 3, 4, 5, and 6? Which order to do them in?
Yeah, just regular order.
All right. So what's the problem with the way this one is written as is? Why can you not apply the quadratic formula right away?
Because the equation is not equal to 0.
That's right. And that's an important thing to make it equal to 0. So you're going to set right 2x squared plus 12x plus 18 equals 0. All right. There is a small little shortcut that you can use to solve this problem, but I'll ask you, I guess, after we go through it this way. Will you calculate the b squared minus 4ac?
Sure. I got 0.
Yes. And that might be a little bit surprising. This one is a perfect square trinomial, which is maybe not clear from starting it. Did your teacher at all talk about reducing this, like dividing everything by the number that's in front?
Yeah.
Okay, I didn't know. I should have asked then. X squared plus 6x plus 9 equals 0. You can still use the quadratic formula, but the numbers are a little bit easier to work with. And when you do the b squared minus 4ac, you still get the same value. All right, so that's good. So from here, we know that it's minus b plus or minus the square root of 0 over 2. Any idea how to proceed from here?
Divide them by 2.
But the square root of 0, what is that?
That would be 0.
It's 0. So it actually contributes nothing. So you can actually eliminate it altogether.
So just minus 3.
Yes. And you might think, well, why is there only one solution? It has to do with the fact that it's a perfect square trinomial. If you were to look at the graph of this, it just touches at minus 3. Is that okay?
Yeah.
All right. So 5 is actually a lot like that one. So why don't I have you try 5 here. I would recommend dividing everything by 3 before you start, and then using the quadratic formula.
Got 0.
Yes. So it's kind of like the last problem. It's minus b. If you divide everything by 2 or by 3, it's let me get rid of this. Straight minus sign. So it's x squared minus 2x plus 1 equals 0. It's minus 2 plus or minus the square root of 0 all over 2 times 1. What does your answer become in this case?
It becomes 1.
Yes, 2 over 2, which is 1. All right, let's keep going. We should be able to finish the next 2. It's been a while since we've actually finished up a full assignment and a lesson, so it's fantastic. All right, so new problem here, number 4. One of the things that I see right away is that this thing minus 5x squared, it's on the left side of the equation. Now you actually have a choice. You can move it to the right, or you can move the 3x and the 4 to the left. I know the preference is to move everything left, but I'm going to suggest that we move it right.
Yeah.
So this is 0 equals 5x squared plus 3x plus 4. And for whatever reason, students get really caught up on notation. If you don't like the 0 on the left side, you just move it to the right.
Yeah.
And maybe we don't like it on the left because we've just seen it that way. You know, we've always seen it on the right when we're doing problems. All right, so from here, go ahead and calculate the quadratic formula. Let me know if you have any questions along the way.
All right. Minus 71.
Sorry, you said you just did the discriminant. Okay. B squared minus 4ac. You said minus 71.
Yeah.
That does look reasonable. AC 80. Okay, that's good. So this is going to be minus 3 plus or minus the square root of minus 71 all over 2 times 5. All right, so this one here, square root of negative 71. You got to look at that as the square root of negative 1 times 71. Square root of negative 1 times square root of 71, which is I. Unfortunately, the square root of 71 does not reduce. It's a prime number. Not sure how you're supposed to know that, but it's you would figure it out eventually because it doesn't, nothing goes into it. So this becomes minus 3 plus or minus I square root 71 all over 10. And then the last little thing to do is to divide each of these by the 10. So minus 3 over 10 plus or minus I over 10 square root of 71. Let me know when you get that down. Let's quickly get the last one done.
Got it.
All right. Okay, so we got last problem here. A is 1, B is minus 3, C is minus 8. B squared minus 4AC is minus 3 squared minus 4 times 1 times minus 8. So this one actually is okay. It ends up being just positive 41. So you have minus a minus 3 plus or minus square root of 41 over 2 times 1. 41 is another prime number. Again, if you tried like 2 and 3 and 5 and 7, you eventually say, oh, nothing goes into it.
Yeah.
So this becomes 3 plus or minus the square root of 41 over 2. And then you divide each of those by 2. So we have x equals 3/2 plus or minus, there's really a 1 in front, 1/2 square root of 41.
Yeah.
Let me know when you get all that down.
Got it.
All right, so I'm going to stop the recording here.